All right, so we're talking about complex numbers, and complex numbers come in the form a plus bi. A is a constant, and b is what you simplify when you're talking about a square root of some sort that has a negative number under it. And in the investigation, hopefully you notice that the purpose of this is when you did the quadratic formula, you got a no solution on your calculator. So the a is really the extraction. Tells you where to move left or right. The B tells you how to move up and down. So it's kind of like, well, does it go right there? Does it go right there? Should it be up here? Where are my intercepts that I'm looking for? And I'm not exactly sure. There could be one intercept. There could be two intercepts. So this number tells you where to imagine, hence the imaginary part, the I, to put it. The biggest thing to remember is I stands for a square root negative 1. So anytime you're square rooting in a quadratic and you get something like this, square root negative 144, I have to bring the I, or the imaginary part, out first, this negative. So I'm like factoring it. So I move on and it says it's I times the square root 144. I square root 144. It's not always going to be a perfect square root. It could be something that you have to factor treat, but in this case, to make it obvious, I just left it that way. So 144, the square root is 12, and there's always, until we're told otherwise, two of these. That's why there's always two roots or two solutions when I graph. So it's a positive 12i and a negative 12i when I simplify that. As far as how do you deal with these things, hopefully you figured out in the investigation that add and subtract is really easy. All you're talking about is combining like terms. The parentheses separate the two imaginary numbers because they have to be in the form a plus bi. So this imaginary number, or complex number, has a negative 3 that's a constant and a 6 imaginary. This one has a 7 that's a constant and a 5 that's an imaginary. So when I combine those like terms, I'm going to add, in this case, 3 and 7. Excuse me, negative 3 and 7. And I'm going to add 6i and 5i. What I get then is 7 minus 3, which is 4, and 6i plus 5i. The i's kind of act like an x or an a or a b or whatever variable you want to call it, so they don't change when I add. I have 6 i's and 5 i's, which is 11 i's. When I subtract, I want to make sure that I'm going to carry this negative, distribute it through. So I do want to change anything that's negative. So this one says 3i minus 4 minus a negative 5, so a minus is a plus, minus a negative 6, a minus is a plus, so my constant becomes plus 6, and minus a positive 2i, or minus 2i. Just like before, I'm going to look for all of the pieces that are the same. So it doesn't really matter what order you put it in. If this one starts with an I and you want to write the imaginary part first, you can. Normally, Beautiful Book Answer puts the constant first. So the constant is negative 4 plus 6, or 2. And the imaginary part is 3i plus 5i. Remember, I'm working left to right, order of operations. So that's 8i minus 2i. 8 minus 2 is 6i.